Bismillahirrahmanirrahim. Today we will start chapter number 3, and that is regarding data modeling using entity relationship model. So, before describing the entity relationship model, it is important to know why there is a need for ER model. For this purpose, we look for this particular diagram, and if you see this diagram, then you will understand the overall database design process. So database design process starts from the given mini world, whatever the mini world you have, because it is the mini world is actually you can say the scope from where we have to determine those requirements, or you can say mini world is your problem domain from where you will extract all those requirements which are required for data modeling. So let's suppose if you want to build a database application for a hospital, so that hospital itself is a mini world for you. So what is happening inside the hospital in terms of data processing, in terms of output generation, in terms of data they want to store, or in terms of queries. So the mini world in that case is that particular hospital for which you want to develop the database model or an application. Similarly, if you want to develop such an application for a bank, then that given bank is your mini world. You have to determine that what are the data requirements of the bank, what type of accounts they are dealing with, what type of clients they have, what type of products they have, and how they manage various kind of transactions, and what data is relevant for them. So the given mini world, or the third example, maybe you take the example of university. Let's suppose if you want to build a university database, then your mini world is that university from where you have to extract that information. For instance, all those courses, all those programs, all those teachers which are there, the students who study in that university, their course details, so on and so forth, all these things become relevant. Apart from that, what type of input is required, what type of output they want to generate, maybe the vouchers being generated, maybe the enrollment card or student card is generated by the university, which contains certain information, or the transcripts or mark sheets which are being generated from the examination or the semester section. So the process is to determine the requirements and analyze those requirements in terms of your data requirements, and then data requirements are then led toward the conceptual design, which is actually a design where you build your high level data model. And the conceptual design includes the possible number of entities you have for which you want to store the data, and also you will try to find out the various relationships which exist among those various entities, and then you will move towards the data model mapping. The concept of data model mapping is transformation of your conceptual design into an actual database, or you can say into a physical design. So once you make your conceptual design, then when you map into the database, actually then you will create that database. And whatever the constraint definitions, whatever the relationships you define, or whatever the cardinalities you mention, or the attribute dimensions you mention, will come reflect into the physical model. And then you can go for the function analysis by by let's suppose by executing various queries and to find out how it works, and then it lead toward the application program design. So this is the flow of the database design process. So for that purpose, if you are talking about A relational model, as we are discussing the relational database model in this course. So, if you want to build the conceptual design for the relational database model, the ERM approach is normally used. ERM stands for Entity Relationship Model, or sometimes we also say it ERD, that is called Entity Relationship Diagram. So that basically builds the conceptual design of any database, which is a backbone of any database. So if you have determined the requirements in a correct manner, then it's the next task is to transform it into a conceptual model. So for this purpose, as an example database in this chapter, we will take the example of a company database, which I will describe in the next few minutes. So we need to know some of the ER concepts. So the ER diagram, or basically is a type of model which is based on symbolic notations. Whenever we perform modeling in computer science, or we use modeling in computer science, we have various approaches. For example, sometimes we opt for the mathematical modeling, sometimes we opt for graphical modeling, and somewhere we use statistical modeling techniques. So here we are talking about ER model, which is the conceptual, which is basically the symbolic modeling approach. It means that here we have the symbols which are being given, which represent a specific meaning, and those symbols will be reflected into the model. So which includes, I will discuss later on the about the entities, attributes, relationships, and various roles of attributes in the relationship types. So we will discuss those various entities and definitions and value sets and key attributes in the next slides. So, for this purpose, first of all, we'll try to understand the various notations we have in the ER diagram. The first notation you see on the top, it represents an entity. It's a rectangular box which represents an entity. Entity is something you can say is it can be a thing, it can be an object, it can be an individual, it can be a place, it can be an event itself, or in other words, you can say event is anything of significance in the given mini world for which we need to store data, or it can be described in terms of various attributes. For example, in the university database, you might think that student is an important entity because we want to keep data regarding students. And whenever you describe that student, you will describe that student the in terms of the attributes. So there we also have the concept of weak entity, and you can see that the weak entity is reflected or represented in terms of a double line rectangular box, which actually represents the weak entity. The concept of the weak entity is actually is that its dependence is basically on the strong entity, or you can say the weak entity actually depends on the other entity for its existence. So, or you can say that in any given mini world, there is no direct requirement of that information, but that information is linked with a certain entity. So, therefore, it is being modeled, or it is required. Then we have the concept of a relationship. As you can see, it is represented in terms of a rectangle, in terms of the diamond box. And relationship, as you know, that whenever we talk about relationship among the entities, so there are three common types of relationships. That is, one is to one is to many, and many is to many. I will explain these three with examples later on. So the double rectangle box here representing a weak relationship. So a weak entity might have a weak relationship with the other entity. So therefore, it is represented as identifying relationship, or you can see downwards the oval shape. The oval shape is represented in terms of attribute. So attribute representing an oval. So let's suppose if we talk about a student ID, student name, student's address are represented as an attribute. Then the next is called the key attribute. So if you think that any of the attribute in the given entity is actually a unique attribute, then you have to have underlined that attribute. And for any given entity, a unique attribute can be a single attribute or a group of attributes. Then we have the concept of multi-valued attribute, which is represented in terms of double-lined oval shape. So multi-valued attribute is an attribute which you have identified in the given mini world with respect to any entity which keep more than one values. And for example, that if I want to keep data about an employee and there is an attribute which is called contact, or a phone contact. So they might have more than one contacts. So if I want to have all those contacts into my database, so I will declare this entity as a multi-valued this attribute as multi-valued attribute. And later on, when we map it into the database, then we will decide what to do. So today we are not discussing the mapping. We are just discussing that how we represent that information in terms of a model. The next is called the composite attribute. Composite attribute means an attribute which consists of some attributes. For example, sometimes we represent name. Let's suppose the employee name. So employee name is can be further divided into first name or last name. So I can say that name is a composite attribute which consists of first name and last name. So that will be represented as a composite attribute. Or take the example of an address. So address can be composite as well. So because the address may be divided into a block, into a street, into a number, into a city. So address can also be broken into sub attributes. So therefore, the representation is like that. You can see over here. The dotted line oval shape represents the derived attribute. What is a derived attribute? Derived attribute is the attribute which takes values from maybe other attributes, or you take some sort of cumulative value, or you calculate some value based on the other values. So that attribute will be represented as derived attribute. For example, if I want to represent the cumulative grade point average, normally we call CGPA of a student. Now, not that CGPA is dependent on various grades which a student obtained in various courses. So that has to be computed and then it will be represented. So if it is represented, it itself is a derived attribute. Or sometime we calculate the profits and sometime we calculate other related things, then it is represented in terms of a derived attribute, a dotted oval shape. And the last three symbols basically represents the participation constraint. And that participation constraint, if you see, is either represented with a double line or with a single line. Here you can say here we have a double line, here we have a single line. So whenever we have a double line, it means total participation of E2. It means all the instances of E2 will participate, but few instances of this entity will participate because this is a single line. It means it is a partial constraint, and double line representing the total participation constraint. Okay, and similarly we have various relationships in terms of one is to many, one is to one, and one is to many, which we will understand later on. Now these are some of the symbolic notations which we will discuss today, but remember these are not the only representation. These representations are represented in the classical ER diagram, but in the next class, we will see that how we can use the extended notations as well. And there we will also see some new notations which may be represented for a problem, for a given problem, or in a given mini world to be represented in the model. So for this purpose, we need to understand a small example, and that example is related to a company database. Here you can see on the slide the an example small case study of a company database is given to you, such that you will be able to develop the entity relationship model or ERM for the company database. So some of the requirements are given to us. So we need to create a database schema, and let's see what a company is. So according to the given information, the company is organized into departments. So let's suppose there is any company and that company has few departments. Let's suppose maybe those departments are referred as marketing, management, finance, or let's suppose any other IT department as well, or production department, quality, and so on and so forth, depending upon the company. So the company is organized into departments. So since we have various departments, each department has a name, number, and an employee who manages the department. So each department has to be recognized with a number which is associated to it, or a name you will give into it. Or the additional thing is that there is an employee who manages the department. So there is one of the employee who look after the department. We keep track of the start date of the department manager. So whoever is looking after the department, we have to maintain the date from which date he started looking after the department. And a department might have or may have several locations. It means, let's suppose a department is located in 3 different places. It may be located in 2 different places, so on and so forth. Each department controls a number of projects. So in this given mini world, there is an assumption that a company is looking after certain projects. And let's assume any company, for example, just for the sake of the example, you can say a software company. So that software company has many projects. So you can say that various project has to be maintained, or the information regarding those projects has to be stored. Let's suppose we're talking about a construction company. The construction company might have various construction projects that has to be represented. So each department controls a number of projects. So department actually controls the projects. Each project is also identified with a unique name, a unique number. Let's suppose any number. You might say a project number is given like P101, P102, so on and so forth, and is located on a single location. So each project itself is located on a single location, not on the multiple locations. The database will store each employee's social security number. So obviously, if we're talking about a company, so company consists of employees, and every company wants to have that data of employees. And that data of employees includes this social security number that is called SSN. So in North America and other countries, normally they have that SSN. But let's suppose if we are talking about our own environment, there might be, we have the employee number itself. You can generate your own employee number, or sometimes you can use CNIC or any other number. So we need to record data about an employee. So their address, their salary, their gender, and birth date. So each employee works for one department but may work on several projects. So each employee works for one department but may work on several projects. So employee is always associated or works in a single department, but it is possible in the given situation that the employee works in several projects. The database, DB refers to the database, will keep track of number of hours per week that an employee currently works on each project. So at any given point in time, the company wants to know that how many hours a particular employee worked on a particular project. Let's suppose employee E101 worked on a project P1, let's suppose for 3 hours in on Monday, and then similarly on the other weekdays. So at the end of the week, the total number of hours spent on a particular project can be calculated, so that their effort per month can be calculated. It is required also to keep track of the direct supervisor of each employee. So each employee is also supervised by another employee. So all employees are defined on a single location. So each employee itself is actually supervised by an employee. So each employee may have a number of dependents. Here, dependents refers to all those relationships which are considered to be a close relationship of an employee, let's say a family relationship, such as the parents, such as the spouse and childs. So these are considered as dependents of an employee. So company wants to keep data of dependent because the company might offer the, let's suppose, the health benefits to an employee and its dependent. So therefore, we need to have that data, and for that purpose, we need to store the record as their name, birth date, their gender, relationship with the employee. So that is the mini world for us right now, to just see that how that information can be represented in the ER model. So for that purpose, I will switch the screen and I will go to share a document and we'll try to build those relationships. So just for the sake of time, I have built a bit structure, but I have not made any relationship among those. So employee and department. So first of all, in the given situation, what we have identified, that there are four possible entities. One is called employee, one is called the department, the third one is called the project, and we talked about dependent. So actually we have the four entities. Just forget about the two boxes which are there at the left and right, that I will show later on, but in the given situation we have only four. So I'll try to build those relationships and represent those relationships so that you can understand that how it is represented. So here in the company database, it is mentioned that employee works on the department. So let's suppose if employee works on the department and I want to represent this as a relationship, so I can put it here. I can put it here so that uh, so that you can see. I add the text here, and let's suppose that is works on, works for, or works on, whatever you want to like. That is what? That is the relationship we have. That is employee works for. Employee works for what? Works for the department. So employee works for department, and you see here that employee works for department. That is the relationship we have. And there is another relationship which exists between employee and department. So it is possible that we might have more than one relationship between two entities. So if that is the case, those must be represented separately. The second relationship in the company database which exists between employee and department is that the employee manages the department. So here I can put here, just for the sake, okay, I can put it here. What I have written, manages. Employee manages the department. So that these are the two relationships which exist between employee and department. So we talked about three kind of relationship which are common relationships which exist among the entities. One is called one is to one, the other one is called one is to many, and third one is called many is to many. So here, that relationship which exists among the employee and department, that I'm talking about works for, and see what is the relationship. So to determine that relationship, we will start from, let's suppose, from employee, and we will read in that manner. An employee an employee. Always start with the singular. An employee works for one and only one department. So from here, we are talking about that employee works for only one and one department. But since it's a binary relationship is a relationship where there are two entities involved. So since it's a binary relationship, so we also see it from here. Our department might have one or more employees. From this side, this is one is to many, but here one is to one. So the relationship which holds will be one is to many. So I will put here the one is to many. You can represent here, let's suppose, in terms of this box. I will just show over here so that you can see. So you can put here, here it will come, here it will come M and many site, and here you can write one. So the relationship that exists among department employee and employee is one is to many. That is, I'm talking about works for. Now let's take the other relationship, that the employee manages the department. So we again, it's a binary relationship. So between the entities, it can be a unary relationship. If it's a unary relationship, it means that single entity is involved in the relationship. If there are two entities involved in the relationship, we call it a binary relationship. If there are three entities involved in a relation, then we call it a ternary relationship. And if we have more entities which are involved in the relationship, that you can say it's an array relationship. So here now see the second relationship. So an employee, again I start with a singular. An employee manages one and only one department. So both the sides there's a one. Okay, now come over here. Never write the relationship cardinality by just reading from one side. That will misguide you. So whenever you are dealing with a binary relationship, you have to see the relationship from both the sides. So an employee manages one and only one department. So I just mentioned from this side. Now you can read the relationship from this side. Our department must have, department is managed by one and only one employee. So from both sides, it is one. So therefore that relationship is represented as one, as one, as one is to one, as one is to one. So I just put it here. So that relationship between, the second relationship is between employee and department, and that is one is to one. How you how you use various how you represent your attributes. The attributes are represented in terms of an oval shape like this. Let's suppose I just write down here the that employee is SSN. This is SSN, and this SSN is represented here. You can see this is the first attribute. Now let's suppose there are other attributes as well. For example, name. So that is another attribute, and what we do is that we connect these with the entity like this. Similarly, I just using these diagram tools so that you can comprehend the subject. So here you can see now in this manner we actually put the attributes. So right now I'm not putting all the attributes over here. So just for example, so that SSN is a unique attribute, so therefore that is represented as an underline. So now you understand these two relationships. Now let's try to discover the relationship between department and a project. And if again you go back to your mini world, which says that a department controls a project, so that is the relationship which exists between department and the project. So therefore I can put here what is the relationship, that is called controls. Controls. So that is the relationship between department and project. So now we'll try to find out whether it is 1:1, 1:many, or many is to many. So we start from here. A department control one or more projects. So from here it is one, from here it is many. And when we see that relationship from the project side, so you can say a project is controlled by one and only one. So from here it is 1:1. From here it is 1:many. So 1:many will dominate. So therefore the relationship is 1:many. So I can put one here and I can put the many here. So that is the relationship which exists between department and the project. So relationship is 1:many and department controls the project. So here you have identified that relationship. Now let's see, according to the given mini world, what is the relationship between employee and a project. So employee and a project, we have a relationship that employee may work in one or more projects. So if you want to write down that what is the relationship that is works on, so I can put here the relationship that is I'm sorry, that is works on. So employee works on project. Now make the relationship employee works on one or more projects. So this side is one, this side is many. Now see from here, a project may have one or more employees. So one is here, M is here, one is here, M is here. So it means from both sides it is one to many. So if a relationship from both side is 1:many, then actually that relationship is many is to many. So that will be represented like this. It will be represented as many as to many. So here you can see the many is to many relationship. Why? Because employee works in one or more projects. A project may have one or more employees. So from both the side, if in a binary relationship, from both side it is 1:many, then actually the relationship is many is to many. So whenever we have a many to many relationship, it is represented as m is to n. So when we speak out, we say many is to many, but when we write m is to n. Okay, the reason is why we don't write m into m, because it makes the sense that from both the side the value will be same. So it is not necessary. An employee might work in 4 projects and there is one employee who might work in 2 projects. So therefore it is always represented as m is to n. Now, one more important thing. Whenever you have many to many relationship, it is necessary that you must have at least a single attribute which is not either defined in employee nor in project. So we have to find out which is the attribute which cannot be defined in employee or in project. So if you see the company database, that attribute is number of hours worked. The number of hours worked in a particular project. So if I want to put this attribute in employee, so there we do not have the information of a project. So therefore it cannot be mentioned over there. If I want to put that attribute in the project, there we do not have the information of an employee. So therefore that number of hours worked is actually an attribute which depends on both the entities. So that type of an attribute must be defined with the relationship here. So I will define this with the relationship. So you can define it like this. And you see, I have defined hours worked. I have defined here the hours worked. You see here? Why? Because that attribute is dependent on both the attributes, that employee and a project. So therefore, it is defined with the relationship. That is M is to N relationship, or many is to many relationship between employee and a project. So we have also discussed the we talked about the relationship between employee and a project. So here, let's suppose I opted for this box. Why I opted for this box? So that because we need a double rounded rectangle or double side rectangle. Why? Because here this representation is for the weak entity. So for this, you can say it is what? It is the weak entity. Here I can write that what is that? Actually, it represents the dependent. It represents the dependent. So why? Sorry for a bit, because I'm working on the word processor. So therefore, there might be some overlapping, but you understand the concept. So this is dependent. So dependent is actually what? Is a weak entity, and its dependence is only on the employee, and because of that employee, the company wants to have that data. So what is the relationship between employee and dependent? Employee have dependents. So an employee might have zero or more dependents. Why? Because there might be no dependent of an employee, or if there are more dependents, then of course it is many. So you can say from here it is one is to many. But whenever I read the relationship from here, a dependent is in relationship with only one employee. So whoever the dependent is, always related with one employee. So from here it is one is to one. From here it is one is to many. So the relationship itself is one is to many. So I can put it here for your understanding. You can see here, and you can also see here one is to many. That is the relationship we have about an employee. That is the relationship of an employee. One last thing which is also represented in the company database is regarding that employee supervises an employee. Now this is self relationship or a unary relationship. Because it's a unary relationship, so it is described with the same entity over here. You can see I can just make this relationship here so that you can understand that how it works. And here you can see that relationship. I can just show you how it is connected. And one more line which I want to mention over here. You can see like this. So we have that relationship, and I want to connect this with one more line to make it correct. So you can see the relationship is like this. Now this is the self relationship of an employee. And what is the relationship? That employee supervises an employee. So here that relationship is supervises. So you can say an employee supervise one or more employee. A employee must be supervised by one and only one employee. So again, the relationship is one is to many. So I can put over here one, and I can put over here the many. So that is the relationship we have between employee and the employee is supervised by an employee, and you can see that self relationship is also defined, which is a unary relationship. So we have binary relationships. You have also observed the weak entity. You have also observed one-to-one relationship. You have also observed many-to-many relationship. And similarly, you can define the various attributes. Like here, you can define the attributes over here, and those attributes are represented like this. Let's suppose it is department number DNO, and this is department name, that is D name. Okay, and you might have locations, so you can also mention the locations. So in this way, you have seen yourself that you are able to develop the conceptual model, that is your ERD, or initial your conceptual design. And as soon as you add more details into it, or you want to represent more concepts into this model, this will become finalized. But right now, whatever the mini world we have in terms of the company database, you see that it is represented in this model. So this one is to one, one is to many, and many is to many is also called the you can say a relationship cardinality, or relationship cardinality, or even the maximum cardinality. You can also represent the participation constraint. How you will define the participation constraint? Let's say, take one example between employee and department. Employee works for one and only one department. Yes, this is participation is total, because if there is any employee has to be work in a department. A department might have one or more employees. In a department, you must have one or more employees. So department cannot exist without an employee. So participation constraint is total from both sides. So if the participation constraint is total, that line will be doubled like this. Just see, for the sake of the example, it will be like this. And if this is also the total, then it will be represent like this. Okay, so employee manages the department. So all employees will not manage the department, only few employees will manage the department. Our department must have a manager. So from one side it is total, from one side it is partial. So you can put the double constraint over here, and I hope now you can add those participation constraints in the other relationships as well. So this is the representation of the conceptual model of a company database in the given example. So we just switch back to our presentation, and if you can go back and see, this is our presentation we're talking about, and the same thing is represented in terms of a complete diagram. And here you can see the complete diagram. This is the complete diagram we have, and you see that all representations, whether in terms of attributes or a composite attribute, it is there. Total participation or partial participation is also there. There is also mentioning of the derived attribute, self relationship, weak entity, weak relationship, so on and so forth. So now it's up to you that how you can understand that concept and try to build the ER schemas for any given problem or a given mini world. So that is the basics of ER, and we will continue to to add some more details, and we'll move toward the extended model, and there we can see how we can represent those relationships. So here you can say all these relationships are defined: works for, manages, controls, works on, supervision, employee, and dependents of. So this is actually, you can say, the concept of the you can we have seen the diagram initially, and in this diagram you can see that you have the mini world, you have the requirement, and you build the conceptual design. So actually what you did is you actually make the conceptual design. So that is your conceptual design. So this is the end of the first lecture regarding entity relationship models, or basics of entity relationship model. I hope you understood the important points which are being highlighted in the lecture, and I hope you will try to read out the related content from chapter number 3. I will recommend you to please go through with this book, which is the official textbook for our course, one of the best books I have seen in the databases, that is Fundamentals of Database System. So we are using the 7th edition, that is by Ramiz Al Masri and Nawadi. So that is normally we called Al Masri and Nawadi databases, fundamentals of database systems. So I will give you an assignment to go through with the chapter, read out the chapter carefully, and when we meet next time, we will discuss some other problems as well. Thank you so much.